So today I'm going to do something that I have never done in my life, and that is to go inside an actual engine factory. Okay, before we begin, some context, what is going on. I'm super excited. Now, I'm actually in Spain, in the beautiful city of Valladolid, in the factory of Horse. Who is Horse? You probably never heard about them, but they're super important, and there's high chances there's an engine of theirs in your car if you're in Europe, because Horse actually, they started as a subdivision, as a part of Renault, making engines for Renault cars, but today Horse is a joint venture between Renault and Geely from China, who pulled together a very, very large amount of resources and expertise and knowledge and R&D and you name it, and now they're making 1 million engines per year. They're making gasoline engines, diesel engines, hybrid drivetrains, and it's all happening right here in Valladolid. And what we're gonna see today is the whole process of an engine taking life from start to finish, because they have a foundry here. They're doing pressure casting. We're gonna see the casting, we're gonna see all the machining, and then we're gonna see all the assembly. So basically from the raw materials all the way to a completely tested, ready for installation engine. Ooh, these are good shoes.
L. L?
L, but I think, let me try. I'm not that big. Okay, yeah. Take 3. Wow. Okay, this feels okay.
Who usually don't like.
What is it? Where do I put this?
Okay, you have to open it.
Open it and put it
And
on.
you put it here. And I will
Because it's loud?
It's a microphone and you will hear us.
Okay, but how will the camera record them?
For the people who's going to be talking, we can put the mic on ours and yours. There's no problem. They're compatible.
Okay, we're going to put every possible microphone on them. Okay. In we go.
We are entering the casting building. I would like to show you this part over here. This is our 3D printing for different parts. Okay, we can see it. We can see it here real quick. We have all these 3D printing machines which are working the whole day. Buenos días. Okay, so what we do is some of the spare parts that we use at the factory, okay, instead of buying these spare parts outside, which are much more expensive, we manufacture these parts internally, okay? So we have real good savings with this
cost
activity.
advantages.
Yes. Yeah. Okay, so so this is an example of a die. We can see here this machine which is making a scan 3D. Okay, so the operator can see which are the dimensional characteristics that need to correct. Okay, because this part is the one that is going to go into the machine and is going to produce when the aluminum melted gets inside, is going to produce that cylinder block. Okay, you have 6 phases. You can see here one of them.
This is the bottom phase,
yes,
right?
Yeah, that's it. This is what we call heavy maintenance. Okay, which is made every 18,000 parts. Doing this heavy maintenance, it takes almost 1.5 months for 2 persons. So you need very high skills over here. It takes us about 3 years to prepare a person. Yes, you have the 6 phases inside, okay, and the die is going to open Okay, and then that robot over there is going to take out the
The completed one.
yes, 2,500 tons, force tons.
So what's the composition? What's the composition?
Well, it's basically it's aluminum, but it has an alloy of. It takes a lot of manganese, silicium, cobre, copper, and those are mostly its little composition. But we have a limit for each component that we check of the furniture. When he sent it to us, the supplier, we check that the alloy is correct. You can see it. Vamos a verlo un momento y vemos una imagen. Hola. So he goes to the different, as you can see here, he goes to the different phases. Okay, he goes sweeping all the part.
Yeah.
You
It
can
lets
see
you see perfectly the internal health
Ah,
of the
yeah,
part and the
that's it.
structure.
That-
What is
exactly.
impossible to see with anything else.
Exactly. Well, years ago, I mean, not here, but usually people what used to cut the part in
Okay.
different, but that's
Many
yes,
layers.
but doesn't
Takes
it's-
too much time
yes.
and
and it's not the same.
okay. We are in.
What we do is cast the aluminium first, and then we apply melted steel on top of the cylinder, and then we machine that. We use two wires, go through a tube, we melt them, and we apply it to the cylinder. You can see there how the two wires are melting. I had a nitrogen push that that pushes the melted steel over the cylinder. As you can see in the previous generation, you needed those lines, those friction lines, so the oil could.
Something to grab on.
Yeah, that's it. But in this technology, we don't need that. We don't need those friction lines. What we need is the porosity of the process, so the oil can go through it and lubricate the engine.
Okay, so the oil is basically getting
it's-
stuck into these little holes. So before you actually put in pre-made finished sleeves, you put them in, and now the sleeve is actually a part of the block. Does that mean that there are no more engine rebuilds, right?
That's it. That's right. That's very true.
This is the traditional one.
The traditional
There's
one.
the crosshatch. This
Yes, and here it has it because the process has it, but what you're looking for is a mirror honing, mirror surface. We don't need the hatch.
okay, because we have the little holes.
That lubricate the
Okay,
cylinder.
this is crazy. Okay,
Yeah,
this
yeah.
is, I had no idea about this. All I
Yeah,
know
it-
about is this.
It's completely different. And you can see here the RFID, as you can see, so you can know this is the data matrix from the casting plants.
It's like a scanner for this or something.
Yeah, every machine has these ones, these scanners that read and write. Here is the PSC. This is the coating process. And you
Oh,
can see
okay.
how
Oh, can I zoom in? Can I move
yeah,
close?
yeah. Hombre, hombre.
I'm gonna do a selfie. Whoever you are, and when this engine ends up in your car, I hope it serves you well. That is so crazy. I wish I could shoot this better. Can I? Is it okay if I just like press stuff?
Yeah.
I'm joking.
Yeah, okay. So what we're seeing is the two wires, the voltage, the intensity, the first nitrogen pressure, the second nitrogen pressure. There are also sparks. So those sparks are ATEX. ATEX means that if you open this right now, it could explode.
Oh,
So you have to suck all of that sparks,
Okay.
and you have also that
So you're
that
seeing
information.
everything live. Why did
Yeah.
it now go? It's finished. It's done.
Yeah, one cylinder, next cylinder.
Ah.
You got the 3 cylinders here,
Okay.
and you can see all of the information you need to know
Yeah.
about the piece.
Real
and this,
time.
yeah, that is real time. Then it registers everything for each part, goes to the Google Cloud, and you can analyze your big data, and statistics, whatever you need.
Yeah.
This will be the torch.
Okay.
This is the main tool of the VSC process. As you can see in this part here, that's the point where the two wires collide.
Okay, where they meet.
Yeah, they meet there. So the wires go through here, and you can see here.
Ah, that's the current. Electric current goes through.
Yeah, the wires go through here. The primary nitrogen here, and the secondary here.
What a tool.
Yeah, and this rotates.
Okay, yeah, to cover the entire
Yeah,
cylinder.
that's it.
And the spray is coming from here, right?
Yeah, that's it. You have a little lid here.
Ah, this is like a nozzle. You have a little
the
nozzle.
That's it.
Okay.
And at that point, you can see that's the point where the welding process is occurring.
And you're putting it. You make a round.
Yeah,
Wow. This is. I've never seen this. This is crazy.
Yeah. These are the wires.
Okay. This is what actually ends up on the cylinder block.
Correct.
Okay.
That's it. The coating is applied.
Okay.
It is rough.
And it looks very rough.
Very rough right now. Most of the machines here are for control, are for cleanliness.
Yeah.
So the machining, what machining is, there's very little. You got like the roughening process, BSC, well, the main drillings and everything else, but everything else is cleaning the parts and controlling the parts.
Yeah.
Like more than 60% of the line. And then you can see here, we can't touch it, but you could notice that it's about 40 degrees, 50 degrees. Okay. Here, well, not very interesting. You do a chamfering. So you do
I know.
chamfer.
Chamfer. Just no rough edges.
That's it.
Okay.
That's what we do there.
Okay.
And
Chamfering is fun. Come on, I like chamfer. A good chamfer gets me excited.
oh yeah.
Okay.
And then you have the high pressure cleaning machine. We go at 500 bars.
Wow.
And what we try, what we do is clean all of the parts, the BSC parts we don't want. Because you can imagine that that's like a spray,
Yeah.
and you can't control it perfectly. So the lower parts gets very filthy,
Okay.
but it's still, it's not like, I don't know, paint or whatever.
Yeah, so you need 500 bars.
You need high power, yeah, that's it. And applied to a certain angle, so you're sure that that's clean.
But it's capable of removing the steel from the spraying process without harming the block.
Correctly.
Which is aluminum.
Correctly.
Which is amazing.
Yes, it is. You can't see much.
Okay.
You can't see much. You had to imagine like a nozzle getting
Yeah.
into
And 500 bar of cleaning.
yeah, that's it.
I have a pair of jeans with like a bad stain. Can I bring them here?
And your leg, if you want,
Yeah.
it will get removed. And these are the molding machines.
Oh.
These ones are very specific.
Oh,
and
this
very
is fun.
Yeah, very difficult machines. Loads of parameters, loads. You got two phases. The rough phase and the finished phase. And then you have the measurement phase.
Okay, here we have it. Finished.
Finished, totally finished.
It's a mirror. It is a
look,
mirror.
This is what I was talking to you about.
I have to show the mirror. Wait.
Yeah.
It is there's nothing.
Nothing. This. And you have imagine like 100 microns there. And have to
Insane.
support all of the pressures, all of the temperatures, everything.
So this is the engine that we have just seen being machined. The engine block, it's the new HR12.
I will try to explain everything I can,
Okay.
and we will see. So to see first here in the engine, we have two quirks for this engine, which are new features here in Renault and Horse, which are the intake manifold. It's refrigerated by water,
Okay.
apart from air.
So it's a water-cooled, integrated together with the intake
Correct.
manifold.
It's like we have a mini intercooler inside the intake manifold. Water pump is electric.
Oh, that's good. That's fun. That's fun. An
48
electric
volts
water pump.
for the thermal engine, 48 volts, and 24 for the hybrid.
Shall we go in?
That's interesting. Let's go. Let's go. Otherwise, you just have to push me. I will stay here forever. Open the doors. Should I go in first? Rah!
Okay, we will stand there so we don't.
So we don't bother the robots, right? Okay.
Here in this side, we have all the flows and logistics. Okay. So normally, what we do to implement this is we do simulations with logistics programs to know exactly how many AGVs we need to carry. AGVs, autonomous ground vehicle.
So basically, you know what's going to happen before it happens, right?
Correct. We are trying to predict everything, so we don't have any
So there's
scary moments.
Oh, okay. Okay, so here we have the main bearing plate, all the bolts at once, and then we have the two yellow things on the side. They're gonna check for axial play in the crankshaft, and then it's gonna go from there over to right here, and then here we have a Yamaha machine that's gonna do the bolting pattern to tighten down the main bearing plate.
Micro percussion for the identification label of the engine. This is mandatory. You need to engrave
Okay.
the engine index, the engine reclamation letter, and the number of the engine.
This is the number. This is where the number that we see in the papers of the car.
Yes.
It appears.
It appears here. You have the number of the car, entire car, and then the number of the engine. This is the engine one.
Yeah, that's the one. That's the one when we grind off when we do an engine swap.
Yes, yes. This is the one you need to homologate
Yeah.
when you change the engine.
Yeah.
And that you hear is an aspiration because it has an aspiration vacuum to hold the bearings there.
Checking this machine, the presence of the.
Piston rings,
Okay.
the data matrix of the conrod itself, piston data matrix also, orientation of both piston and conrod, and this circlip.
Okay. The circuit of the wrist pin. Okay.
So this is an electric press with a lot of thresholds to control you are not breaking the segments. Because if not, you are going to consume oil or don't have good compression, whatever.
When you say segments, you mean piston rings, right? Okay.
Yes.
Just to be sure.
Segment is
I know.
in French.
Segmentos. Segmentos. So this is a machine that's pressing onto the bucket. It's pressing onto the gasket material, and it's going through that, and then applying the gasket material onto the oil pad. So let's see that up close.
Okay, so we have all the controls here of all the timing accessories.
It has timing marks. We still have timing marks.
Yes, we have timing marks.
Thank
and there
God.
is- this one is copper color. So you need to have the arrow into the copper color tone. You see it here with the other primers.
There's a copper-colored link in the chain.
Exactly. You can see here the timing chain, and you can see the copper color marks. Obviously now they are not in position because it moved after its position. But it checks that everything is in position and then moves all the engine to prepare it for the clutch. Here we have the pulley, crankshaft pulley. Crankshaft pulley tightening, nothing is very special. It's just a big tightening.
Yeah. Impact gun and 20 agadagas. Ah, there it gets the dipstick. The dipstick was installed.
In the
Okay. Oh, this guy almost ran me over. He was sent by Chat GPT. Let's go the other way around.
All the final assembly, everything wires, the catalytic converter, turbo, everything. We do a helium test, mandatory helium test, 100% of the production. It's like an aspirator
Okay.
that sniffs all the engine to look for helium. This one.
Ah, you put
You can
helium.
see the,
You put helium in the engine, and then there's somewhere that sniffs to see if the helium is escaping.
exactly. It controls the number of helium molecules that
Okay.
it's sniffing.
Okay.
If it's higher than it should be, then we have a leakage in the combustion circuit.
Very important question. Do you have a problem with floating engines?
Okay, here be careful with AGVs because the rolling bases are.
A lot of Chat GPT minions. Oh, there's the dyno. That's the dyno.
That's dyno. We will go into back 5, which is the next one. The newest one.
And imagine people get worried when they blow an engine. Look, there's so many. Why are they worried?
This is the bank we are going to see. Okay? So be careful here, please don't hit anything. Hola. Venimos a grabar. No sé si estás avisado.
Sí.
Sí, ¿no? ¿Te podemos grabar sin problema?
Sin problema.
Muchas gracias.
Gracias, muchas gracias.
You have sound, very important, because here the operator hearing is very important. Normally the bank, the hot bench operators are trained to hear any noise,
anything that's even a
crickling,
bit
any
strange.
squeak. Exactly.
There is so much.
There's so much to connect, that's why we have 15 minutes. And it's very important to do it carefully.
Yeah, I mean, I would mess this up like a million times every day. This takes concentration and focus, and we are probably disturbing this man.
It's doing the electric test first, and then it starts.
Can I move there? Oh,
Yes. This is only when it rotates. Now it's not rotating. Starting.
Está llenando el carburante, el agua.
It's filling the circuit,
water and petrol.
circuit and
Voy a empezar a
petrol.
arrancar.
Now it's the cycle going to start.
Okay, so I'm back at my hotel, and that was the whole process from start to finish, from raw materials, from aluminum ingots to a running, living, breathing, signed off engine ready to go into a car. And this was probably one of the more incredible experiences of my life, and it completed for me a very special triangle of engine-related experiences, because I did a lot of theory and talking about engines and understanding and explaining. I did working on engines myself, building them, assembling them, modifying them. And now finally I have the final piece of the puzzle today, where I got to experience hands-on from start to finish the process of mass producing a large amount of engines from a very large OEM manufacturer. And I have to say that I gained some very deep, newfound appreciation of the incredible amount of logistics and planning and cleanliness and quality control and just sheer overall effort from everyone involved in the process, so that you can ensure that you not only manufacture 1 million engines per year, but that each of those engines actually works and runs properly. And I mean, it was a challenging shoot for me, because I never shot in an environment like this, where it's very dynamic and there's a lot of noise. So maybe I'll have to fix some footage and, you know, do some voiceovers or something. But I don't know how it turned out, but I'm really excited to work on it. But even if it's not all perfect, I hope that we all got the message, the gist of it, because we all got to see some really incredible things today. And for that, I have to say a massive, massive thank you to Horse for the privilege and opportunity that I have given today, and for everybody at Horse for their incredible hospitality and all the effort they put into making it possible for me to see everything I wanted to see, because I was super nerdy and asked to see everything, you know, and they really went all out to ensure that I got to see and shoot everything that I wanted. So a massive, massive thank you to everybody at Horse. This really, really was special. And to you, as always, thanks a lot for watching, and I'll be seeing you soon with more fun and useful stuff on the D4A channel.